Hey everyone, Mr. Newman here, and today we're going to look at the quadratic formula again and a specific part of the quadratic formula. Before we get to that, I want to show you guys three very similar parabolas. Notice this, all these parabolas are kind of the same shape, just shifted up a little bit, but the first one has two places where it intersects the x-axis, two x-intercepts. And remember, we also call those zeros, so there are two zeros on that first shape, and the equation for it is right below the parabola. The second one has exactly one zero. Notice how it just barely touches the x-axis at the bottom of the parabola, at the vertex. And that is actually the only time that a parabola will have exactly one solution, is when the vertex is on the x-axis. The third shape has no zeros because the parabola does not cross the x-axis, so there are no solutions for that parabola. I'm going to look at the three equations here, and I'm going to use the quadratic formula on each of these to figure out the solutions, and I want to show you guys what happens. So, this first one we plug in the quadratic formula, and the second one we're going to plug in the quadratic formula, and the third one we plug in the quadratic formula. I did all that for you. And you notice on this first one, you have, because of that 8 at the end, that's really the only thing that's changing in all three of these, that is the C term. The 8 combines with all the rest of the stuff, so we have the square root of 4 when I get to that step. On the middle graph, we have the square root of 0 because of the way that 9 works with a negative 6 squared minus 4 times 1 times 9. And over here on the right, we get negative 8 under the square root because of the 11, that's C. So the difference here between these three is just what is inside the square root. Everything outside the square root is all the same. That 6 plus or minus and that are all divided by 2. But the inside of the square root is the only thing that changes. That means inside that square root must have something to do with whether we have two solutions, like in the first graph, one solution, like in the second graph, or no solutions, like in the third graph. Let me go ahead and solve this for you, and we'll see what happens. So in this first one, we get two solutions because we have plus or minus 2. That was what the square root was. And the plus and the minus give us two separate values. And so we get two different numbers, 4 and 2. In the middle one, though, we have plus or minus 0. You know that when you add 0 from a number or you subtract 0 from a number, you get the same thing. You get that number. So plus and 6 plus or minus 0, 6 plus 0 is 6, and 6 minus 0 is 6. So either way, it's going to be 6 over 2 or 3. On the third one, however, we have a square root of a negative 8, and you can't take the square root of a negative number, at least get a real number. So because you can't get a real number out of it, there are going to be no places that intersects the x-axis. So notice the differences here. On the first one, we have a square root of a positive number. On the middle one, we have the square root of 0. And on the third one, we have a square root of a negative number. That is the way we use the discriminant to figure out how many zeros there are. And what's nice is, if we just look at that part of the quadratic formula that's inside the square root, we don't have to solve the whole quadratic formula. We just need to do that one piece, and it'll tell us how many roots there are. It won't tell us what the roots are, but it'll tell us how many there are. So, that last one has no solutions because of the negative. Let's go ahead and look at this discriminant. The discriminant is exactly the part of the quadratic formula that is inside the square root. However, notice there's no square root on this because we're just looking at that number. So b squared minus 4ac, aka the part of the formula under the radical. Radical is a fancy word for square root, okay? So, like we said before, if that is positive, if b squared minus 4ac is positive, then we have two solutions because the reason is because we have plus or minus a number, and that gives us two different solutions, the plus a number and the minus a number. If, however, b squared minus 4ac is exactly 0, then we have one solution. The reason for that is because the square root of 0 is 0, and plus 0 and minus 0 are the same number. So it only gives us one solution. The third situation is as if the discriminant is negative. If b squared minus 4ac is negative, then we would have no solutions. And the reason for that is because you can't take the square root of a negative number and get a real number. You can't have the square root of a negative number. Now, one other little thing I want you guys to look out for. Notice I put a little star here. If b squared minus 4ac is positive, that means there's going to be two solutions, but the way those solutions look is if the discriminant is a perfect square, meaning if you can take the square root of it, then you guys have noticed, then we do take the square root, and you get a nice, we call that a rational number. A rational number is one that you can write down as a fraction. Any whole number or fraction is a rational number. So if we can take the square root of it, in other words, if it's a perfect square, then the zeros are rational. If it's not a perfect square, then we have to leave it like a square root. So otherwise, the zeros are irrational. That means we need a square root symbol in the answer. Let's try a few practice problems. First off, use the discriminant b squared minus 4ac to quickly tell how many zeros there are. Notice we're not looking for the solution. We just want to know how many zeros are there. If a is 1, b is negative 3, and c is negative 4, then I'm going to plug this into the discriminant. So b squared minus 4ac. Let's see here. B squared minus 4ac. Negative 3 squared is 9. Negative 4 times 1 times negative 4 is positive 16. And 9 plus 16 is 25, so the discriminant is 25. That's just the value of what b squared minus 4ac is. So that means there's exactly 2 zeros because it's a positive number. 25 is a positive number. If there are 2, then what are the nature of the zeros? I need to answer this next question because there are 2 zeros. Well, 25 is a perfect square. That means that there are going to be 2 rational roots. So the nature of the zeros, I'm just going to write the word rational. Let's try the next one. If a is 1, b is negative 3, and c is 4 now, then the discriminant is going to be b squared minus 4ac. That's 9 minus 16, which gives us negative 5. So the discriminant is negative 5. That means there are exactly no zeros, or 0 zeros. There are no solutions. And the reason is because negative 5 is negative. If the discriminant is negative, that means there are no solutions, or no zeros. So I can write not applicable there because there are no zeros, so there's no nature to them. Now, for this third one, b squared minus 4ac, a is 1, b is negative 2, and c is 1. This time we have negative 2 squared minus 4 times 1 times 1. That's 4 minus 4, which is 0. So the discriminant is exactly 0. So there, I didn't realize my grammar is off here. There is exactly 1 0. I didn't consider the situation. I was just thinking 2 or 0. But if there's 1 0, we should say there is exactly 1 0. If there are 2, what are the nature of the zeros? We don't need to write that. Well, what we could say is they're actually rational because when you add 0, there's no square roots in it anymore. So it is always going to be rational when the discriminant is 0. All right, let's try the next one. A is 1, b is negative 5, and c is 4. Here we have negative 5 squared minus 4 times 1 times 4. So 25 minus 16, that gives us 9. So the discriminant is 9. That means there are exactly 2 zeros. Since there are 2 zeros, we need to look at the discriminant to see whether it's rational or irrational. 9 is a perfect square. That means our solution is going to be rational because we'll be able to take the square root of it. All right, a is 1, b is negative 2, and c is negative 5. Here we do negative 2 squared minus 4 times 1 times negative 5. And we get 4 plus 20, which is 24. This discriminant is 24, so it is again positive, which means there are exactly 2 zeros. However, because 24 is not a perfect square, that means that our 2 zeros are going to be irrational. Thank you very much for watching.